Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start Lecture 4 of Module 3. The topic of the lecture is Atmospheric Circulation, Concepts, Models and Tricellular Meridional Circulation of the Atmosphere. The video is being bifurcated into two parts. This is the first part of Lecture 4. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM-PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lecture, we have discussed in detail the horizontal circulation of winds in terms of planetary wind circulation. And today in this particular video, we will be discussing the atmospheric circulation, the various concepts which are related to atmospheric circulation and various models which define the atmospheric circulation. And finally, we will be discussing the tricellular meridional circulation of the atmosphere. So let's begin. The main objective of this particular video is to understand the general circulation of the atmosphere, which will include the old concept of general atmospheric circulation and thermal model of air circulation. Besides that, we will also discuss modern concept of general atmospheric circulation, which will include the single cell model of atmospheric circulation and tricellular model of atmospheric circulation. But in this particular video, that is part 1 of lecture 4, we will be discussing the old concept, and under the modern concept, we will be discussing the single cell model of air circulation. The tricellular model of air circulation will be discussed in part 2 of lecture 4. So let's start with the discussion of general atmospheric circulation. Wind. What is wind? Wind is the horizontal movement of air from areas of high pressure towards the areas of low pressure across the Earth's surface. And this horizontal movement of air can occur wherever the atmospheric pressure conditions are favorable. So we have already discussed the horizontal movement of air near to Earth's surface in terms of planetary wind systems, which are based on high and low pressure belt systems across latitudes. So we have discussed the movement of trade winds, the equatorial westerlies, the westerlies in the temperate regions, then polar easterly wind systems in the higher polar latitudinal areas of the world. However, this horizontal movement of air or surface air circulation is part of bigger atmospheric circulation system. And today we know that the atmospheric circulation has a vertical component and it involves the upper air atmospheric circulation also, besides the horizontal surface air system. So today we know that the air circulation is vertical as well as horizontal. It exists near to ground surface in terms of horizontal wind systems and also in terms of upper atmospheric wind circulation. But this understanding came much later. Understanding of air circulation became critical in climatology since explanation of various existing weather phenomena events depended on it. And several concepts and models were discussed, were developed in order to provide a realistic approach in understanding the Earth's general atmospheric circulation. So, with whatever information we had in the earlier times regarding the Earth and atmospheric systems, the models were developed to define the general atmospheric circulation. So, we have old concept which defines the mechanism of general atmospheric circulation, and it is primarily a thermal based model. In this initial time period, the thermal based models were developed. Thereafter, as the understanding of the Earth and atmospheric systems improved, the modern concept which defines the mechanism of general atmospheric circulation, they were developed. And these models are primarily dynamic models which are dependent upon several known factors, and they are constantly improved with the added understanding of the Earth atmospheric system. So the modern concept includes the single cell model of atmospheric circulation and three cell model or tricellular model of atmospheric circulation. So these are the three kinds of models which were evolved in order to understand the general atmospheric circulation. We will start with the old concept of general atmospheric circulation. Thermal concept or old concept of general atmospheric circulation. According to the old concept which describes the mechanism of general atmospheric circulation, the movement of air was considered to be temperature dependent. So as we know that the lower latitudes receive more direct insolation as compared to the polar latitudes which receive indirect insolation. Therefore, the lower latitudes or the tropical areas become much more warmer as compared to the polar areas which remain colder throughout the year. You can see that clearly there is a latitudinal imbalance in the amount of energy which is received from the sun. Considering the sun as the major source of heat and energy to the earth, the thermal concept considers that the tropical areas receive maximum energy, which substantially decreases poleward. Thus, the lower latitudes receive more energy as compared to the polar areas, and therefore they become much warmer as compared to the higher latitudes. So we have discussed in previous classes also that the areas which are located from 0 degree to 30 degree north and 30 degree south of equator receives very high direct insolation from sun, which makes their average temperature warmer throughout the year as compared to the polar areas which receive indirect insolation throughout the year. Therefore, the average temperature of these higher latitudes or polar areas remain lower throughout the year. Due to the latitudinal variation in the amount of solar radiation received in different regions, it created the latitudinal heat imbalance, with lower latitudes being energy surplus and higher latitudes being energy deficit. So because of the direct insolation between 0 to 30 degree north and south of equator, these regions are energy surplus. Contrary to this, the higher latitudes, because they receive indirect insolation, the regions are energy deficit. So considering this, there is a transfer of heat through horizontal air circulation near the ground surface from lower latitude towards the higher latitudes in order to balance this temperature variation. So with the limited knowledge about the Earth's atmospheric system and various influencing factors which affect the general atmospheric circulation, only the horizontal circulation component of the air circulation was considered at that point of time when the old concept was developed. So the entire atmospheric circulation was based just on the horizontal air circulation near to ground surface, and it just included the horizontal air circulation, which today we know that is a subpart of a bigger atmospheric circulation system. So at that point of time, because the old concept was entirely based upon the temperature, it was considered that in order to balance the temperature differences latitudinally, there is the horizontal air circulation from the lower latitudes, which were energy surplus areas, which were receiving more insolation, to the areas which were energy deficit, which were receiving less insolation. So horizontal air circulation in terms of ground winds, they started blowing from the areas of energy surplus region towards the areas of energy deficit regions. And this horizontal movement of air particularly started in order to balance the heat energy and in order to equalize and reduce the thermal gap between the energy surplus areas and energy deficit areas. Therefore, the winds move out from the regions of energy surplus towards the zones of low temperature or energy deficit areas. So you can clearly see that the old concept was clearly based upon the thermal settings or earlier understanding of the temperature conditions which exist on Earth. So the old concept was a very simplistic version of what we have today in terms of air atmospheric circulation system, because it just considers the horizontal movement of air, and that too in a very simplistic version. It does not consider factors like Coriolis force, rotation of Earth. So it simply defines general circulation as the horizontal air circulation near the ground surface from the energy surplus regions or lower latitudes towards the energy deficit regions or higher latitudes in order to counterbalance, in order to equalize the temperature conditions for the entire Earth. As the thermal model was based on the limited available information about the Earth and its atmospheric system, so definitely there were some issues, some criticisms regarding the old thermal model of the general circulation of atmosphere. So one of the first criticism or one of the first issues were that it only considered the horizontal component of air circulation to describe the overall circulation of the Earth's atmosphere. But today we know that the air circulation also has a vertical component. But at that time period, because of the limited knowledge, only the horizontal component of circulation was considered. Besides this, it does not consider Earth as a rotating planet and ignored various factors like Coriolis force, which affect the wind movement, the direction of wind movement as we know of today. And also it did not consider the potential energy which was generated by the unequal heating of Earth and its atmosphere and its continuous transformation into kinetic energy. So it is important to note that the potential heat energy is continuously transformed into kinetic energy by the vertical movement of air, that is the upward movement, as well as the downward movement, as the explanation of the general circulation of atmosphere in the thermal model was entirely based upon the horizontal component of air circulation near the Earth's surface, and it completely ignored the vertical movement of air. Therefore, various associated factors like the existence of kinetic energy, the conversion of kinetic energy, the dissipation of kinetic energy due to friction, all were not considered, which led to a less realistic model of general circulation of the atmosphere. Therefore, it failed to consider the factor that there should be a continuous balance between the rate of generation of kinetic energy and the rate of its dissipation, due to which the model was less realistic model of the general circulation of atmosphere. Due to these factors, it was criticized and modern concept emerged explaining the general atmospheric circulation of Earth as the knowledge about the Earth's atmosphere and Earth's atmospheric system improved. Today we have the modern concepts, modern theories which consider the horizontal as well as the vertical component of atmospheric circulation. As the knowledge regarding the Earth's interiors, Earth's atmosphere, Earth's surface, it improved. Definitely various factors were taken into consideration which influence the general atmospheric circulation on Earth. So new modern theories began to emerge explaining the mechanism of general circulation. So the modern concept or modern models which explain the general atmospheric circulation of today consider the air circulation beyond just the horizontal movement. It does not only take the horizontal movement at the ground surface but also at the upper atmospheric level and also the vertical component of air circulation, and they considered that the horizontal movement of air which we feel near the ground surface, which we know of today in form of different latitudinal wind systems, are part of giant atmospheric circulation system, and it is much more complex and it resembles much like a giant conveyor belt with horizontal as well as vertical component of air circulation. So you have a horizontal component at the ground surface, and then you have the vertical component, and again you have the horizontal component at the upper atmospheric region. So our atmospheric circulation today is much like this conveyor belt, which is continuously in motion, transferring energy not only from one latitude to the other latitude, but also in the upper atmospheric region. And this entire continuously moving giant conveyor belt helps in the redistribution of heat latitudinally throughout the globe and maintains the average temperatures on Earth, maintains the heat budget of our planet. So let's see what different models were developed under the modern concept to explain the general atmospheric circulation now. Under the modern concept of atmospheric circulation, based on the initial information and knowledge of the Earth's surface, the single cell model of air circulation was proposed, which later on developed into three-cell model of air circulation or tricellular meridional circulation model of the air circulation in the atmosphere. So let's see what are both these models. One of the earliest models which were developed under the modern concept of air circulation was the single cell model. So considering the horizontal and vertical movement of air, the single cell model of air circulation was proposed by George Hadley in 1735, which is also sometimes known as Hadley cell model. And this initial cell model was primarily a single cell model which describe the circulation of air from the lower latitudes to the higher latitudes in form of horizontal component of air as well as the vertical component of air. So the model explains how the land heats up at the tropics and air moves away from the equator towards the polar areas. So we have discussed this several times that the lower latitudes receive direct insolation from sun, because of which the temperature of the lower latitudes is warmer as compared to the polar areas, which receives the indirect insolation throughout the year, because of which the average temperature in the polar areas is low. So naturally the equatorial areas or the lower latitudes gets warmer and the air molecules start expanding and becomes less dense, and they also begin to rise upward. So because of high temperature, the air in these areas near the ground surface also becomes light, becomes less dense, and it starts ascending, leading to low atmospheric pressure in these areas. Contrary to this, in the polar areas, because of low temperature throughout the year, the air remains dense. Therefore, the atmospheric pressure is high. So you can see the difference here now that the temperature is influencing the pressure conditions across the latitudes. In the polar areas, because you have the low temperature, you have high pressure conditions, and in the lower latitudes, you have high temperature, therefore you have low atmospheric pressure conditions. Naturally, the air above the equatorial region starts lifting, and on reaching the upper regions of the atmosphere above the equatorial areas, it diverges towards the polar areas in both the hemispheres. So because of existing high pressure in the upper atmospheric regions, the ascending air from the equatorial areas, after reaching a certain height in the troposphere, it diverges towards the polar areas. And once the warm air reaches the South Pole and North Pole, it starts descending because of the existing high pressure at the ground surface. And in the process, because these areas in the North Pole and South Pole are very, very cold, the air also cools down and starts sinking, maintaining the high pressure conditions at the ground surface. So you can see clearly that the warm and light air is rising from the lower latitudes, and it is vertically ascending towards the upper atmospheric regions, showcasing the vertical component of the atmospheric circulation. And again, after reaching in the upper atmospheric regions, after hitting the tropopause, it cannot rise further, therefore it diverges in the opposite direction towards the northern polar regions as well as towards the southern polar regions, again in the form of horizontal component of air in the upper atmospheric regions. And finally, it again sinks at the polar areas, again showing the vertical component of air. Now, once the air sinks at the polar areas, it travels back to the equatorial areas as the surface winds away from the polar areas. So we already know that the polar areas, because of low temperature, have high pressure conditions at the ground surface, because of which as soon as the air from the upper tropospheric level sinks in these higher latitudinal polar areas, it tends to diverge at ground surface because of existing high pressure at the ground surface. And the sinking air is pushed towards the lower latitudes because of existing low pressure near the equatorial areas. And once the air moves out from these polar areas at the ground surface, it is pushed from behind by this sinking air which is coming from the upper tropospheric level. This creates a large cell of air circulation in the northern and southern hemisphere, which is called as Hadley's cell, which explains the air circulation wherein due to high temperature the air becomes light, it ascends near the equatorial areas, and on reaching near the upper tropospheric level, it tends to diverge towards the polar areas in both the hemisphere. But because of very low temperature and high pressure at the ground surface in the polar areas, the air sinks near the polar areas, and these polar areas lead to divergence of air at the ground surface, which are further pulled towards the existing low pressure region at the equatorial areas, therefore completing the entire large cell of air circulation, depicting the circulation of air from the equatorial areas towards the polar areas and back from the polar areas towards the equatorial areas. So as the air move out from the polar areas towards the equatorial areas near the ground surface, the temperature of this air parcel increases as it moves towards the lower latitudes. So this process of warm air rising from the equator and then traveling towards the poles to cool down before making its way back towards the equatorial areas is a never-ending cycle which is known as Hadley cell or the single cell model of air circulation. So it is still not that complicated model, and through this single cell model both the horizontal as well as the vertical component of air circulation were discussed by Hadley in 1735. The single-cell model of air circulation is clearly depicted by this short animation which was developed by European Space Agency to depict the Hadley cell or single cell model. So you can clearly see that because of high temperature in the lower latitudes, the warm air rises and it diverges on hitting the upper tropospheric region or tropopause, and it diverges towards the polar areas in both the hemispheres. And as soon as the air sinks towards the polar areas, it cools down and it leads to high pressure at the ground surface. And contrary to this, you can see that because of existing high pressure near the polar areas, the wind tend to diverge at the ground surface from the polar areas towards the equatorial areas. And in the process, while traveling as surface winds, the winds also becomes warmer as they approach the lower latitudes. So this single cell exists in both the hemisphere. One single cell exists in the northern hemisphere, another single cell exists in the southern hemisphere. And this circulation is called as the single cell model. So definitely there were some issues with the single cell theory also. Although George Hadley accurately described the air circulation near the equatorial areas, wherein he said that because of the intensive insolation, the air expands and ascends towards the upper atmospheric level. However, he discarded many already known information about the Earth to make his model much more simpler, because of which the single cell model became less realistic version of the actual circulation of the atmosphere. Following issues pertaining to the assumption of the model were criticized. First of all, he only considered that sun directly heats up the equator whole year round with the same intensity. Although we know today that different parts of the earth receive different amount of sunlight due to tilting of earth on its axis also. Although equator receives high amount of insolation throughout the year, but the highest temperatures are not recorded over equator but slightly poleward near the tropics, near the Tropic of Cancer and near the Tropic of Capricorn. Also, these regions receives very high precipitation, which reduces the overall temperature at equator. So we know today that although equator receives fairly high amount of rainfall, but the highest temperatures are seldom recorded over equator, rather they are recorded slightly 20 degrees north and 20 degrees south of equator. Therefore, his assumption of equator having the highest temperature and sun heating equator with the same intensity throughout the year does not stand correct, and it greatly affects the circulation of wind, especially in the lower latitudes. Besides this, he discarded the rotation of Earth. So his assumption of non-rotating Earth was not true, and he discarded the fact that the Earth rotates on its axis. Today we know that Earth rotates on its axis, which causes wind to deflect from one direction to another direction, primarily because of the apparent rotation force, which is Coriolis force. So when he discarded the rotation of Earth, he mainly discarded the existence of Coriolis force also. Therefore, the winds which were blowing from the polar areas towards the equatorial areas as surface winds were shown blowing at 90-degree angle, and there was no deflection in their direction. So it also does not stand true. It gave a less realistic version of the actual circulation of the air. Besides this, he also assumed that water must cover Earth uniformly. This assumption, considered by him, was also not correct, as the northern hemisphere we know today has more land as compared to the southern hemisphere, which has more water. So definitely the heating and cooling of the northern and southern hemisphere, the patterns of heating and cooling of northern and southern hemisphere are different. Therefore, these patterns definitely affect the surface wind circulation. Besides this, his very concept of single cell model was questioned when two large Hadley cells formed in the northern and the southern hemisphere, as we have seen in the last video. So instead of one single cell, as he proposed, we can see that we have a single cell model for the northern hemisphere as well as for the southern hemisphere. So as opposite to the name of the model, the single cell model, we can see two large Hadley cells forming in both the hemisphere. So these were the criticisms of the single cell model. However, his very description of air circulation primarily at the lower latitude stands correct, wherein he said that due to intensive insolation, the air rises from the equatorial areas towards the upper atmospheric region, and on reaching the upper atmospheric region, on hitting the tropopause, it diverges poleward in the opposite direction. One wing moved towards the northern polar region, second wing moved towards the southern polar region. So his description of air circulation for lower latitude still holds importance as of today. As more discoveries were made, the single cell model required revision. And since George Hadley did not take into account all the behavior and all the factors on Earth that may impact the circulation of air in the atmosphere. So considering various factors and also with the added information regarding the Earth and its atmospheric systems, three-cell model or tricellular meridional circulation model of the atmosphere was proposed later on. And we will be discussing the tricellular meridional circulation model in part 2 of this particular video lecture in the next video. Summarizing the video now, understanding global air circulation is important for understanding world climates, weather patterns, and climatic regions across latitudes. The global atmospheric circulation model is a simplified version of how air currents in the atmosphere move. It is used to help explain weather patterns and climatic regions across latitudes, and several attempts in the past have been made to explain the circulation of the air over the years. While the old concept of air circulation was temperature dependent and gave a simplistic explanation of air circulation, wherein winds primarily moved from the regions of high pressure towards the regions of low pressure at the ground surface. Contrary to this, in the new concept with the added information and knowledge about the Earth's atmospheric system, the models developed under the new concept were based on several existing dynamic factors of Earth atmospheric system like the Coriolis force, the rotation of Earth, the kinetic energy, the latent heat of condensation, and several others. And based on that, a very comprehensive model was developed to describe, to explain the existing air circulation in the atmosphere. And the new concept primarily talks about the horizontal as well as vertical circulation of air on the rotating Earth. So unlike the old concept which primarily talks about the horizontal movement of air at the ground surface, the new concept or modern models talks about the horizontal as well as the vertical circulation of air at the ground surface as well as at the upper atmospheric level. So under the modern concept, initially the single cell model was developed by Hadley to describe the air circulation along the latitudes. He undertook the horizontal as well as the vertical air circulation conditions and developed a single cell model explaining how the land heats up at the tropics and air circulates away from the tropical areas or the equatorial areas towards the polar areas, and further it circulates back from the polar areas to the equatorial areas as surface winds. He gave a comprehensive model initially depending upon the understanding during that time period of the forces of Earth and variable other factors. Although this particular model described the air circulation quite accurately in the lower latitudes, in the equatorial areas, in the tropical areas, with single cell formation in each hemisphere. But the model ignores many important factors like the rotation of Earth, non-uniform Earth surface, and Coriolis force, which has a significant impact on the direction and movement of winds on Earth. In order to overcome the shortcomings of the single cell model, tricellular meridional circulation concept was propounded later to add on to this single cell concept which was given by Hadley. And this tricellular meridional circulation model till now is one of the most realistic model describing the atmospheric air circulation on Earth. And we will be discussing the tricellular meridional circulation in the second part of this video lecture 4. So I hope this video was informative. Thank you so much. And please watch on to the part 2 of video lecture 4 to understand the tricellular meridional circulation model of the atmosphere.